Can you hear me now? Ah, good. That probably you could hear me before because I had music and then I stopped the music. Okay, folks. It's a looks like it's a minute after, so I'm going to get started. And let me actually really get started here. There we go. Hopefully, you are all seeing an AIS Tools demo screen pop up. Anyway, I'm going to take one quick message and then get back to this. Okay, I think we're good. Okay, well, anyway, welcome to my AIS Tools demo. My name is Gary Kessler, and well, welcome to the beginning of DEF CON 29. And in any case, so let me just get in this. So my name is Gary Kessler. Here's some information about me. So I actually took my first computer programming class back in 1973, and accidentally broke my first mainframe computer in 1974. I think that was a function of my taking my first programming class in 73. In any case, I first purposefully crashed a computer in 1976, and then started occasionally finding flaws in operating systems and breaking into people's accounts when I was in grad school in 77. And back then, information security was you found a flaw, you went to somebody and said, "Hey, I found a flaw," and they say, "Well, yeah, okay, don't do that." So that was sort of what I did. But I'm engaged one way or another in cyber. We didn't call it cyber back then, but since about the late 1970s or so. And so my background primarily is in mathematics and computer science. My real specialty is in network protocols. But I'm also a scuba diver and a scuba instructor. I'm a longtime boater. I've got a captain's license. So my interest in AIS actually sort of comes naturally. But up here's a list of some of the stuff that I do. I'm real active with cyber stuff in the Coast Guard Auxiliary. I was a visiting faculty member at the Coast Guard Academy in their cyber systems program 2 falls ago. And last year and this year, I also teach a class in maritime cyber up at the Academy. And last year I wrote a book about maritime cyber. So I do tell my wife that I'm retired. She sometimes says things to me like, "I don't think that word means what you think it means." But, anyway, that's a little bit about me. And I am a principal consultant with Fathom 5. I mustn't forget that since that's right at the top of the page. In any case, so I'm going to talk, about this stuff here. A little bit of a brief overview for AIS for those of you who may not be really familiar with it, but there are certain aspects of AIS I really want to focus on as part of that overview and architecture. So there is a PowerPoint. You can see I'm working off the PowerPoint now. The PowerPoint primarily is giving me a script for some of the stuff that I want to talk about and show you. And I'm not 100% sure how the PowerPoint becomes available. Probably one of the goons can help me out with that, or we'll get it over to you via the Hack the Sea Village, or worst case, you'll send me an email and I'll send it to you. But anyway, AIS is of interest to boaters, and of course, as I said, I'm a mariner, and I've got a computer science background, and several years ago at either Black Hat or one of the DEF CONs, Marco Balduzzi and his team from Trend Micro started talking about AIS cybersecurity vulnerabilities. And that's really what, sort of got me interested. So basic background that I'd like you to know about is AIS is a tracking system that's used by ships, maritime authorities, vessel traffic management systems, basically to provide situational awareness for ships in the immediate area. And by immediate area, I mean an area of 10 to 20 nautical miles. And AIS was designed during the 1990s, after the wreck of the Exxon Valdez in 1989. And it didn't become a requirement for vessels until about 20 years ago. But the point of this page is the ships aren't really transmitting to each other. What the ships are really doing is they're transmitting radio broadcasts over the air, and I'll talk a little bit more about that. But they're basically just broadcasting their own unique, quasi-unique identifier, their position, course, speed, possibly things like their destination, and that kind of stuff. And the data can be displayed, on any number of screens, including mobile apps. So I said that AIS wasn't a requirement until about 20 years ago. So the Safety of Life at Sea agreement of 2002 is where AIS became a requirement. And as you can see here, AIS is required on really big ships, cargo ships, passenger ships with, more than 150 passengers, or at least certified to carry more than 150 passengers, certain commercial vessels. There's a warship exemption, which is something that we will readdress later on. And a lot of smaller vessels also carry AIS equipment and also are transmitting their positional kind of stuff. So I've got a slide here showing an example of what this might look like, but I'm going to give you something slightly more useful. So there's a program that I use a lot in my research called Opencpn. Here it is. You can download Opencpn online. There is a version of Opencpn for Linux and Unix systems, which of course includes Macs. There is a version for Windows. I've not used it. There is a version for Android, and the latest that I've downloaded on my Android phone is sort of iffy. I believe that iOS is one of the few operating systems for which there is not a version of Opencpn. I also have this running on a Raspberry Pi with their operating system. But the basic idea of an ECDIS display or any sort of chart plotter is, you see I've got these little boat icons here. And if I just mouse over, I learn at least, oh, okay, there's something about the boat. And I'm not so concerned about the ones that are, sitting at a dock. I'm going to scroll down here a little bit. This, by the way, is in the area of Ponce Inlet, Florida, so near Daytona Beach. So here I've got the tugboat Catherine. And if I right-click and do a target query, I get information like, well, there's the tug. I mentioned a quasi-unique number, the MIMSI, the Mobile Maritime Service Identifier. So this number identifies the AIS device. It does not identify the ship, although generally there's only one AIS device on a ship. In any case, this is giving me the lat and the long. It's giving me speed, course, bearing, all that kind of stuff. And, if I back out here a little bit, let me close this and back out of Opencpn, I start to get an idea of where, some of the vessels are in the area, although right now it's not a great deal of activity. Oh, there's one. Let's see. That's the Forever Young. I know nothing about the Forever Young. Let's see. It's an unknown type of vessel that's 0 meters long and has a 0 meter beam. Okay, that's not likely. But, in any case, you get whatever information has been programmed into the device, which, by the way, is a very important point that I may as well mention now. I have no idea what vessel this is. It says it's the Forever Young, but I actually don't know. That's been programmed in. You'll notice that they're not telling me what type of vessel they are. They could be a trawler, could be a sailboat for all I know. But again, that is, one of the issues with AIS that we'll probably talk a little bit about later on. Anyway, I'm going to let all of these things keep popping up here, and let me go back to this. So the Ais Communication Protocols that I care about. First of all, again, this is all radio transmission. AIS is defined in an International Telecommunication Union recommendation, M.1371, and you can download M.1371. And all of the vessels are going to be communicating using some form of time division multiple access. Now, the most common one that's described is called self-organized Tdma. And with self-organized Tdma, basically what happens is a ship gets within range of other ships. And when it starts to make any change to the way it is currently broadcasting, because there's only two frequencies on which to broadcast, and as the slide says here, there are time slots, and each time slot's about 26 milliseconds. As it starts to move to a different area, the ship has to listen, and it has to listen, I believe, for something like 2 minutes, because then it can determine which time slots are being used and which ones aren't being used. And once it determines that pattern of use, it now basically grabs a time slot and reserves the next time slot. And as long as it can keep using that time slot, it's happy. It's only when it has to, because it has moved to a different area, that it has to start worrying about, I have to start listening again to figure out, where I speak. There's no central controller, which is why, all of these boats are using a distributed process of, self-organization. Now, I'm giving a talk later on in the Hack the Sea Village on Ais Protocols, and I'll talk a little bit more there about the National Marine Electronics Association and their set of protocols. But there's something called Nmea 0183, and the ITU adopted Nmea 0183 format and a speed of 9600 bits per second, and that's what they use for over-the-air AIS kind of stuff. So just to give you a little bit of a taste of where we're going to be going. These are the AIS protocols, and the only one that we're going to worry about are the Nmea 0183 encapsulated ASCII sentences. I'm not going to tell you how to build a sentence specifically, although I'm going to show you some tools that will allow you to do that. I'm not going to talk about the rest of it, how I frame HDLC and all that kind of stuff. I'm just going to show you the ASCII sentences themselves. And let's see, what else do I want to tell you? I think that probably will be good enough for that. So what this page is trying to show, again, is the elements of the AIS network. So this is showing all these Class A vessels. And again, the arrows are not meant to imply that the ships are talking to the other ships. They're merely broadcasting, and these are all the other vessels that can hear their transmission. Now, AIS does provide a capability where one ship could send a message to an addressed receiver. So, in fact, you could have a vessel talking to the Vessel Traffic Management Service, or more likely the Vessel Traffic Management Service sending a message to a specific vessel. But in general, this is just, all the messages are going to a broadcast address. I show here an AIS-capable satellite. AIS over satellite is not real-time communication. And again, since the range is only over about a 10 or 20 nautical mile range, you can see that I don't need the satellite to be, or rather, I don't need satellites for real-time comms, not over, that kind of range. What happens is there are a bunch of satellites that are AIS capable, and what they're doing is they're essentially reading all the AIS traffic while they're moving around the globe, because most of these are not geostationary satellites. And then what they do is, for whoever put them up there, periodically, they just download all of the AIS traffic that they have been accumulating over time. So anyway, so that's why we have the satellites. Primarily, it's data aggregators, the vesseltracker.com or, findship.co, those kind of places, the data aggregators. They're the ones that are getting the satellite data. What I don't show on this page is a Class B vessel, but in fact, a Class B vessel would be doing the same thing that the Class A's. I do show here a Class A because it's not communicating with the others. The non-AIS vessel, when I take a fishing boat offshore, I don't have AIS on board. So I don't get the benefit of, or at least provide the benefit of AIS. Now, there are a variety of ways where people can build their own very inexpensive AIS receivers. Last year at DEF CON in Hack the Sea Village, I gave a talk about how to do that. And one example is go out and get a Raspberry Pi with something called a daisy hat, and and an appropriate antenna, and you're in business. And what I showed last year was putting the daisy hat on the Raspberry Pi, installing Opencpn, and connecting a TV monitor, and boom, you're there. There are a variety of other devices you can buy that will be AIS receivers, as shown here. Nothing I say is necessarily a product recommendation or a reference, but there are a lot of options out there. Anyway, and like I said, once you have downloaded or built your hardware, which you can do again relatively expensively, you can go get software like Opencpn, and I've already shown you that. One of the cool things that Opencpn will do, by the way, is if you go into connections here, or rather, if I go to options and I go to connections, there's this Nmea Debug window, and what it will do is it is showing me, based upon my source here, this is showing me my real-time traffic. And we will talk more about places you too can get traffic. If you're interested in Daytona Beach traffic, you can go to the address that's shown there, and to that port, obviously. There are a variety of other places where you can also download real traffic, but I get it from my area. Anyway, I'll let that run for a little while. Now, I mentioned Marco Balduzzi earlier. Balduzzi and his team have written a bunch of papers, as I said, about AIS and some of the security vulnerabilities. I have not gotten to the point of building a transmitter because for the research that I was doing and the kind of stuff I was trying to do, I wasn't really interested in actually transmitting any stuff over the radio. I know it can be done, so I didn't feel the need to resolve that problem. I was working on other stuff. However, the paper there that I am showing you is one you can go that talks in gory detail about how to build a software-defined radio transmitter. One of the tools I'm going to talk about shows you how you can build AIVDM messages, those are the AIS messages, to send out over new radio. And again, I'll show you that when we get there in a couple minutes. But again, I mentioned Balduzzi and the work that they did because basically they really inspired what I did. My focus again is on message generation and payload encoding. I don't worry so much about the other stuff because there's code that will do that for me. In Balduzzi's paper, they also show how to build an AIS transceiver. So, again, here's their antenna, there's their new radio setup, and all that kind of stuff. Anyway, all of that really was preamble. So let me tell you about my AIS tools. So the Trend Micro folks in one of their early papers built a set of tools called the Ais Black Tool Kit. And the idea was that you could craft what are called AIVDM packets. And you could put, is the information that says there, you could put in location, core speed, all that. It turns out in AIS that is referred to as a type 1 message. There are a couple other types that'll do that as well. But even if you can't read anything else here, you can see that there's a MIMSI, there's a latitude, there's a longitude, and what's happening here is they're building a message that has the MIMSI, the lat, the long, has some other default information, and then passes all that information to a program that will send this out via new radio. That's what the Black Tool Kit did. And latitude 44, longitude 8, apparently looks like it is in this area. which I probably should have checked first to see where this was. But in any case, what they have done is they're spoofing an Italian vessel, and you can see the little chart of the course that they've laid out here. Now, the Black Toolkit is really cool, but what the Trend Micro folks were trying to do, I think, was to make a point about some of the security vulnerabilities with AIS, and so they didn't build what I would say would be standard compliant software. So, for example, if there was a parameter that they didn't enter, they just made up a default as opposed to using the standard default, which was fine for what they were trying to do. I was trying to do something, a little bit more than that. For example, if you don't put in the latitude and the longitude in the Ais Black Tool Kit, you end up someplace in Italy. But that's not actually the default because, for some of those values. So I don't mean that as a criticism by any means. I learned a ton from the Ais Black Tool Kit. But like I said, for what I was trying to do, I needed something a little bit different. So here's the Ais Black Tool Kit at GitHub. Let me move around to get over there. So here's the Black Tool Kit, and there is the URL, but if you look it up at GitHub, you'll find it. You'll notice that everything that they've done was written in Python. I don't like Python, but I'll talk about that later. You'll notice that there is exactly one Perl program here, AIVDM_pre. So the problem that I had when I was playing around with the Black Tool Kit was if I wanted to assemble a message, I had to use a command line tool that I had to use the right switches, and I had to know what switches went with what, type message and all that kind of stuff. And so, while again, I was learning how this all worked, I found that appropriately confusing. So I built a menu program, this so-called preprocessor, and all it does is it asks you, what type of message do you want to create? And if you say, I want to create a type 1 message, it asks you for all of the parameters that are in a type 1. And then it creates the command line tool in the Ais Black Tool Kit that will, the AIVDM encoder, so that it can now create the message within the Ais Black Tool Kit environment. So this was my contribution to the Ais Black Tool Kit. And it was the beginning of what I was going to be doing next. So if you're looking to fool around with AIS messages, there are really two good sources. One of them is the standard itself, the M.1375, or go to a guy named Eric Raymond's webpage, which is entitled AIVDM, AIVDO Protocol Decoding page. And this is also currently up at GitLab. And this is a page that I used as a reference. It was, the best online resource I could find. And I've actually contributed some to this as well. But you can see with the table of contents there on the left, all the kind of stuff it has. But it basically tells you how you would encode the standard. It does make direct reference to M.1371. Let's see, it tells you what the sentence structure looks like. I'm going to talk about that in a second. It talks about various things such as, these are called encapsulated sentences. They're used armored ASCII. This is what armored ASCII looks like. And then what we really care about is the different types of messages. There's 27 of them. I'll mention that more in a sec. And then he goes through and tells you type by type, what do the bits look like in all of these fields. And this gives you an idea of how you too can generate any of the messages that you want. And again, between this and the standard, you get a really, really good idea of how to build these kind of messages. Now, again, my focus was on the broadcast messages. That's why M.1371 is relevant. if you're talking about AIS transmissions by a device within the skin of a ship, sort of all bets are off. At that point, you really need to rely on the NMEA standards, all of which are proprietary. But for the over-the-air stuff, Eric Raymond's page is really top-notch. Anyway, so like I said, I built my own set of tools, primarily because about 3 years ago, what my area of interest is not that I needed to verify the trend micro work, but I really wanted to explore more about the trend micro observations about AIS lacking bit integrity, timing integrity, and authentication. And so last year, again at DEF CON, at Hack the Sea 2020, I talked about a protocol called Protected AIS, which was just sort of a demonstration of capability of the fact that you could add some security mechanisms to AIS and retain backward compatibility. So that's what I was trying to do. So I needed to build some tools that could craft messages the way I wanted them to look like. For those of you that are familiar with HPing 3, that allows you to craft pretty much any TCP/IP message that you want, that's why I called this AIS ping, because it turns out I designed it so that you can craft legal AIS messages. But if you can craft a legal message bit by bit, there's absolutely no reason on earth you can't craft an illegal message. And so it's interesting to know, well, what happens if I send out messages with illegal values? So if I was going to craft messages that might not be valid, I needed to have a parser. So I built my own parser. And then I decided, well, wouldn't it be cool if I could copy messages that were live over the air and then save them with a timestamp? Because one of the things that AIS messages don't have, and let me go back and show you this. So you see the Nmea Debug window up there. So you'll notice that there is a timestamp, and there's also a source of where this data is coming from. That's because it's coming from Opencpn and displaying on my computer. But everything there that starts with the exclamation point or the bang, AIVDM, that's the only thing that's coming in over the air. There is no timestamp over the air. So I wanted to have a capability, let's see, going back to here. Oops. I wanted to have a capability where I could actually grab live AIS data, save it with a timestamp so that I could replay it at with the same relative timing and all that kind of stuff. So that brings me to this. All of those programs there in blue are part of what is in my AIS tools. And so let me just sort of quickly run you through this. So the first thing I have there is a Readme file. I generally don't brag about my Readme files, but I'll show you this in a second. So the idea is this. I've got this Ais Menu program, and presuming you know what your data is that you want to put in, you can run the menu program, and you can create a command line to go to Ais ping. Ais ping is the actual program that creates the input. It creates a binary output that becomes the input to a program that will create AIS sentences. And that's what is called their AIS_NMEA. You don't need to use the menu program to get into the ping program. You can use just a command line. Ping can output binary that's going to go to the Nmea program to create sentences, or it can go to the Ais Black Tool Kit program, AISTX.py, that is designed to create an actual, RF feed. Then, of course, I have a parser. So if I give it some sentences, I can parse out the data. And for some reason, one day I decided, well, somebody might want to parse data and, put it out to HTML file. So anyway, that's why that's there. So before I go too much further, I sort of have to say, I started writing code, well, as I said, back in 1973. And then for any number of reasons, I got out of writing code sometime in the, and about 15, 16, 17 years ago, I decided to pick up my soldering iron again. And the choices at the time really were Perl or Python. And the truth is, I didn't like Python very much. At the time, there were two versions that were not necessarily compatible. The looping potential to have off by one errors in looping, I thought was interesting. And the fact that it uses white space as delimiters, I thought was not very friendly for people who want to write code in a text editor and or who want to quickly read code and see where things are delimited. And so I started using Perl. That is the only reason that all of my code is in Perl. In any case, having said that, let me scroll around here and let me show you the README. So the README that comes with the toolkit actually is almost essential reading to at least get started with my tools. It tells what all the tools do. It is a little bit of a user guide for how to use them, although all the tools pretty much have a help file. The menu doesn't. I have to freely admit that I don't support all 27 types of messages. I only support 22 of them. Now, having said that, these are the 22 that I've actually seen in use. I have not seen the other 5, seen actual data. So these are the more common ones anyway. Let's see. So then I talk about the fact, okay, you run the menu program, you get the ping program that looks surprisingly or unsurprisingly like the encoder program that is in the Ais Black Tool Kit. And the ping program, which looks like where I'm highlighting here, gives an output of a command line with binary that could be used for the Nmea program. And the output of the Nmea program is an actual AIVDM sentence. So I'm going to show you all that in a couple seconds. What I really want to point you to is that in the README is also a list of all the parameter switches that are supported by all the programs and which parameters relate to which message types. And then beyond that is the format for all the messages, bit by bit, what all the fields look like. Eric Raymond's page gives a little bit more detail. What is the message type and all that kind of stuff and how to encode all the fields. This is really just a way that I could organize the code. So when I was encoding and parsing stuff, it would just keep everything straight. There are comments in the code that include all that stuff as well. And then last but not least, there's a couple of programming techniques that I used. I mean, nothing really weird. I mean, it's all straight stock standard, Perl, Python, C kind of constructs. But I talk a little bit about how we handle signed integer values. There is really no floating point used in the AIS messages. If they want a real number, what they do is they scale it and then encode it as an integer. But the integers can be positive or negative, so you have to do a couple tricks so that works out. And so anyway, like I said, I've got a couple programming notes that are discussed in the README file. So as I said, the README file is sort of, essential reading. So the first program to start with is the Ais Menu. And as it says here, it's, an interactive program. So let me just play with that. Let's get over to here. I think I'm in the right place. So, live demos are always, prone to risk. Oh, so far, so good. Anyway, so here's what the menu program looks like. So at this point, I merely, make up what kind of message do I want. So let's say I want to type one message. Hit a 1, and there I go. There are a number of talker IDs that are available. And by a talker ID, we mean what is the type of device or station that's creating this message. By default, it's a mobile AIS station, which is why it would start with an AI, so that's option 3. If you just hit enter, it'll take the default. And then there's a number of encapsulation formats. And it can be a VDM or VDO. And you may remember from Eric Raymond's page, it was the AIVDM AI encoder. So the difference between the two is an AIVDO message is a message that you are sending, whereas an AIVDM message is a message that you are receiving. In all of these cases, since I built a receiver, all I'm seeing are AIVDM messages. But just for kicks and grins, if I want to use something non-default, I hit 2 and I get, AIVDO. Then it wants a MIMSI, the Maritime Mobile Service Identifier. You have to have one of these or nothing else works. So here, 1, 2, 3, 4, 5, 6, 7. This is not a valid MIMSI, but that's okay. The program doesn't know. And then I need to include other stuff that would be included in a type 1 message, such as the navigation status, which tells me, am I underway? Am I at anchor? Am I in a variety of priority states, such as restricted in my ability to maneuver or constrained by draft? You can read what's there. The default is not defined, so if you hit enter, you get 15. What the heck? I'm going to say we're moored. And then you have to put in the rate of turn. The rate of turn is a value that you would get from a sensor on board the vessel, telling you whether you're turning right or left. So let's say, let's see, how do this is up to some number of degrees per minute. So I'm just going to choose, I'm turning to the right at, 20 degrees a minute. Enter my course over ground. Let's say my course over ground is 180. Let's say my true heading is actually 190 because sometimes you're not headed in the same direction of your course due to tide, wind, whatever. I can enter my speed in knots if I know it. Let's say I'm going 23.2 knots. I actually have a funny story about that. I at my house, which is like 8 miles from the river, so I can't pick up anything because the antenna's on the floor. I once picked up a boat going 55 knots. And I was ecstatic that I picked up anything. But then I realized when I looked at the latitude and longitude that the boat was in the southbound lane of I-95. So it was undoubtedly a boat on a trailer. And that's why I only got, one piece of data. Anyway, my latitude, let's say my latitude is 29 north. My longitude is 81 west. I don't really care about the rest of this stuff. But now you'll notice it asks me where I want the output going. Do I want it going to an Nmea format, or do I want it to be able to go under radio format? So, if I do nothing, it'll choose Nmea, and then there's only 2 frequencies you can transmit on, called channel A or B. So if I do nothing, it'll go to channel A. So, you can see that this sets me up. It gives me a command line for the ping program, and you can see all the information that we typed in there is there in with all the command switches and stuff. And then it ends. The thing I really want you to see is it ends with Nmea equals A, because this is a command that will set me up with an Nmea message on channel A. Now, for the same amount of money, if I ran this again, let me set up I'll do something different, type 5 message. And I'm still going to use AI. I'll just leave it with the default, 1, 2, 3, 4, 5, 6, 7, 8, 9, same MIMSI. And in this case, it's asking different questions. So let's say this is a device, here, we're going to use combined GPS and GLONASS because we don't want to rely just on GPS anymore. I don't happen to have an IMO hull number, so I'm not going to give that. ETA of where I'm going. Well, I'm going someplace. Let's see, it's August 6th. I plan on being there by, I don't know, let's say 8 p.m. UTC. It didn't like that. Let me put in the 20. And now it wants the minute. I'm going to be there right at the top of the hour. The draft of my vessel, I can, 2 meters. And my destination, I don't know, there. Whoops. I really can't spell, can I? Ponce, that'll be fine. And I don't care about the data terminal status. my vessel name. There. My daughter's favorite boat name, and I don't have a call sign. And I don't know, I'm a fishing boat. Lots of stuff in this, and I'm not putting in, well, I should put in something. Let's put in 3, 3. So this is telling me how long and how wide my boat is. Now, really where I wanted to get was down here. If I want to make output to go into, let's say, radio, like a new radio, hit P instead of N. And let's say I want to transmit on channel B. So there's B. And so you'll note again, if you look at the ping command, it's got all the stuff that we just put in, but the very last parameter, tx equals b, means we're not going to make an Nmea sentence. We're going to make something that is going to go to the new radio program out of the Ais Black Tool Kit, and we're going to transmit on channel B instead of channel A. I mean, it's that simple. You could also change this, by the way, by merely copying the ping command and changing that last parameter by hand. There's absolutely nothing that would, prevent you from doing that. So for example, I'm getting a little bit ahead of myself, but if I were to copy this ping program or this ping command right here, and I paste it right there, I'm just going to go back now and dash Nmea equals B. Okay, it's changed. It's just pretty much that easy. So I'll come back to what all this jazz means here in a second. Let's see. So in the PowerPoint, there's some of these same examples, or they're actually different examples, but similar functionality. So that brings me now to the ping program. So the idea is I just use the menu to create a command line for the ping program. And again, the ping program is designed to create the Nmea formatted encapsulated AIS message. And again, as it says here, you can generate binary output for my own Nmea sentence generator or the Black Tool Kit AISTX program to create radio output. So let me just go back here. I'll just tell you what this is all about. So I just used ping a second ago with this type 5 message. And so what it did is it just created for me a command that I can use with AIS Nmea.pl. So if I take this and just copy all of it at the command line, its output is going to be 2 sentences, which you sort of see there at the bottom, where it says, the Bang AIVDM 213, blah, 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 and then the next one, 223, blah, blah, blah. For that matter, I could go back up here to the type 1 message that we just created. The type 1 message, again, being the position information. And that creates, obviously, as you would expect, a different binary string. And if I use that, I get this AIVDO message. So basically, we've taken whatever information you have, and I've now created an AIVDM message that is going to be, rife for transmission if indeed that's what you want to do. Now, again, I created this, again, for my research purposes, but it also does call into question, well, suppose I had invalid data, like a latitude and longitude that just didn't make any sense. Or worse than that, I put in a value that was in fact just a value that the standards had accommodated. In most cases, if you have a field of X bits, the standard has given you 2 to the X possible values. In some cases, there are gaps. So for example, if I'm going to put in a course, and let me actually go back up to the menu where we at some point had to put in a course. Let's see. Speed and knots. Oh, okay, here we are. Your course over ground is going to be degrees from 0 to 359.9, or you put in 360 if the data is not available. Well, suppose you put in 385. What happens? When you enter your true heading, which is the next line, they want a number from 0 to 359 or 511 if the data is not available. What happens if you put in 452? Now, I would have to believe that most AIS equipment, upon seeing a totally bogus value like that, would merely say, that's a totally bogus value, we're going to ignore it. On the other hand, you never know. How do you debug unless you can actually, test those cases? So that's really where I was, sort of going. Anyway, so again, the pages in the presentation, give you some of this as well. And again, you can easily change the ping command line, which is going to be very important for us later on, because I have a couple demos I want to show you, and I want to show you how you can create yourself an entire script of stuff, but you only have to, start out with one value and one ping program or one ping command, and then you can just edit it. In any case, that brings me to the Nmea I just sort of showed you. It gives you the output from ping, gives you command line input, and that command line input to Nmea is a binary message, and then from the binary, you can create the encapsulated payload. I'm not going to talk actually any more detail about what the binary looks like, but of course, we know what the binary looks like because Eric Raymond's page showed us, and the standard showed us, and for that matter, even my readme.txt file showed you what the format of the messages are. In any case, again, here you're taking binary, as I showed you, you're getting an encapsulated message. One hint, by the way, when you're looking at this stuff, and you'll figure this out pretty quickly, the first 6 bits of the message are the message type. So this 000001 obviously is a 1. Well, you'll notice that in the encapsulated message here, which starts after the A comma, there's a 1. The reason I'm showing you that is because if I go here, and this is an example of that type 5 message, well, after the A comma in the first message, the first character is a 5. So it's real easy to quickly look at the first byte of the encapsulated output, and you can see what the different type messages are. And even if I go to the real data that's scrolling out here over the air, almost all of this, well, let's see, we have some H's. Okay, so these are Class B devices. So here we're getting a type 8. The H and the B, it's a little bit more obscure because of the way that they encapsulate the higher digits. But most of the Class B devices, which are those devices that are broadcasting AIS but don't have a legal requirement to do so, they're using type 19 messages. And so again, it looks a little bit different. Let's go back here. And okay, just in time. Here's what an encapsulated AIS sentence looks like. And I'm not going to go into this in terrible, byte by byte detail, but I'd like you to be able to look at this and understand what you're looking at. Whoops. So here's all the pieces. In the Nmea 0183 standard, this first character, in this case the exclamation point or the bang, this is the delimiter that says you now have an encapsulated sentence, or you have an Nmea message. Most of the messages, if you're familiar with GPS messages, they all start with a pound sign, or the hash, or the sharp if you're a musician. And that basically says we have what's known as a parameterized message. So it means that all of the parameters are in a comma delimited list, and they're actually quasi-human readable. The exclamation point says this is a formatted message using special encapsulation. The next 5 characters are the talker ID, the AI, and the VDM, which is saying you're getting, voyage data information that's coming in. And then it's followed by 3 numbers. So this output here is called a sentence. One AIS message may be larger than the capability of one sentence, which is around 168 bits. And so the next 3 values following the AI VDM, one of them is an indication of how many sentences are in this message. In this message, there's 1. The yellow number is, well, which sentence or fragment number is this? Well, this happens to be obviously fragment 1, since we only have 1 fragment. And then the 3rd field, which is null, would be the serial number if I needed to reassemble fragments. So actually, purposefully gave you an example that had 2 sentences for exactly that reason. If you look here, sort of mid-screen, you see that where I gave it the type 5 message, I gave it all of this binary, and it gave me 2 AI VDM messages. So you'll notice the first message, in the first field, it says 2, because there's 2 fragments, 2 sentences in this message. This is fragment number 1, and we're using serial number 3. 3 is just a made-up number, so that we have a serial number for reassembly. Anyway, so 2 fragments. This is fragment 1, serial 3. The next message says there's 2 fragments. This is fragment 2 of serial number 3. This is how these 2 can be reassembled if they were transmitted. Because, in fact, right up here on the line that says armored ASCII, that is the entire armored ASCII message. But it's too long for 1 sentence. That's why we needed to fragment it. Now, since I'm here, at the end of the armored ASCII piece, the armored ASCII piece needs to be an even multiple of 6 bits. So the number that follows the comma sign is the number of padding bits. How many bits did I need to add to get this message up to be on a 6-byte boundary or 6-bit boundary? Obviously, that's going to be a value from 0 to 5. In our first fragment, there's no padding, and you wouldn't expect any padding in any of the initial fragments. In fact, the only time you should ever see a non-zero number is if you have a single sentence or in the last fragment, the last sentence of a multi-sentence message. And indeed, down here in the second sentence, we have 2 bits of padding that have been added. They're not shown here, but they are indeed thrown on over here. You can see them actually here in the binary, but because you'll notice that the last bits here, I probably should have looked at this earlier, but here's the entire binary, and you can see here the 0, 8. Well, this already has the 2 bits added on. And so this tells me I've got 2 padding bits. In any case, that is followed by an asterisk and a 2-digit number. The asterisk says the next field is the Nmea checksum. And the Nmea checksum is merely an exclusive OR of everything between the A in AIVDM up to the number before the asterisk. So again, this is sort of the, this is the format for what an encapsulated sentence is going to look like. I told you all of that so I can tell you a couple other things. You may have noticed, even for me, it was a little bit cumbersome running the menu program and then copying and pasting the ping command and then copying and pasting the Nmea command. For a bunch of reasons, I made these 3 separate programs, primarily because you don't need to use the menu to get the AIS command, and the output from the ping program, while it's going to go through the Nmea program, ultimately, the ultimate output may be an AIVDM sentence, it may be something different. So I decided to build a script that, once I was on a roll for things, I could just run a shell program in Unix or a batch program in Microsoft Windows. I don't remember how to write a batch program in Windows anymore because I haven't used Windows in a lot of years. So I do thank my friend Glenn Dardick for coming up with the batch program. In any case, what this basically does is you run the aistools.sh, the shell, and it'll run menu, puts all the output to a temporary file that becomes input to AIS ping, and then that becomes input to AIS Nmea, and boom, you run the menu program, and out comes an AIVDM sentence. So let's see. Well, I'm not going to demo the shell. I think you guys probably get the idea with the shell. So after making all of those messages, we now have the issue of, well, how do I know sort of like, what they look like? So here's what I'm going to do. There's another program called the Parser. The Parser takes either a binary string or a binary string on the command line, or a binary string that's in a file, or one AIS sentence that's on a command line, or one or more sentences that are in a file, and it then parses them. So without being too terribly mysterious, so let's take this message right here, this AIVDO message. Going to copy it, and I'm going to run the parser, AIS_parser. Since I can't spell, I really need to use the tab more. So in this case, the input's going to be a sentence. Now, I don't believe Windows users have this problem, but on Unix, there's so many special characters in the command line, I have to, escape out of them. So if there's any, non-printable characters, not non-printable, rather, non-alphanumeric, like the @ symbol and the equals, you'll notice I'm putting a backward slash in front of them. Just to make sure that they get interpreted exactly as they're written there. Anyway, so here's what the parser will do. At the top there, it shows you the actual command line. It then parses and says, okay, this is from a mobile AIS station, and it's a VDO sentence. It's the own vessel report. The checksum is correct. Here's the binary string that translates into, and then here's the parsing. So it's a type 1 position report. Here's the maritime service ID. So the maritime service ID has in it somewhere a 3-digit field called the maritime identification digits field. Apparently 555 belongs to the UK. Oh, belongs to Pitcairn Island. Let's see, wasn't that mutiny on the Bounty? Okay, I should have checked. In any case, it gives me whatever information it can on whether this has a valid country code in it. Anyway, and then down here, the status. Remember we said we were moored, and remember we said we were, well, I used the value 20 here, which turns out because of the formula, turning to the right 18 degrees per minute. Here's my speed over ground, my position accuracy, my longitude and latitude. For some reason, I was always taught latitude and longitude, but the standards always have longitude first. Oh, by the way, I can then copy that line right there. And if I go to Google, let's open up a new window. Open up a new window, I say. Okay, so now if I go to Maps, oh, I don't need to do that. If I just take the actual URL that I just typed in, it'll take me to 29 North, 81 West. And let's see where it thinks it is. Usually it goes faster than this, but of course this is a live demo, so why would it go fast? All right, I think we're in the middle of some water somewhere. Okay, before I can paint this whole thing blue, 2981 is in the middle of Smyrna Beach, south of Route 44, west of 95. I probably should have tried, or when I put this in, if I'd put in 80, pretty sure that puts me in the middle of the water. No, apparently not. Okay, well, I'm going to stop trying to make this work, because never trust a live demo. I've got other stuff that'll work. Anyway, so that's what the parser does. It does, like I said, exactly what you would expect it to do. I clicked on that. Yeah, that's pretty much what it does. Now, some people have expressed that they like to have HTML output. So what I decided to do was just build something that would convert this to HTML. So, for example, let's use the same parser command that we had, but now what I want to do is I'm going to pipe the input to parser to html.pl, and now I want the output, let's say, going to, what's today's date? 2021-0806.html. Okay, so now if I go to the browser, and again, let's hope that this works. If I go, if I try to open, let's go here. Let's go to prototype, and there, 2021-0806.html. It should take the output, and oh boy, it looks like HTML. This link, by the way, becomes a clickable link, as useful as it was before. But in any case, again, same type of information. It just looks like HTML. And so for people who want HTML, you got that there. 29.5 minus 81. Yeah, that puts me off of Flagler Beach. So that really is over the ocean. Now, the cool part of what I was trying to do, once I got to the point of being able to, make AIVDM commands and parse them, and that allowed me to go off on some of my research about how to add some form of security to this, is when I got the idea of, well, it'd be really cool if I could just access some data. So the problem is I needed to get the data and maintain a timestamp. And so I decided to use a comma delimited file. Actually, it's pipe delimited because I needed to find a character that wouldn't be used in any other AIS type of application. And so let me go over to here. I'm still in timestamp. Okay, so I mentioned that all of the programs have a help file. I actually didn't show you what they all look like. So AIS ping, for example, doesn't like that. Let's go with help. Let's make it unambiguous. There we go. So the ping help file gives you, an example of the most minimal AIS ping command you can have. You must have a type number and you must have a MIMSI. These are the possible type values you can have. A MIMSI, have to specify it. But this talks about all the other that ping supports, and it gives an idea of in what message types might these appear, and again gives you in just a couple words a reminder of. And so that's what's in ping. In NMEA. It just tells you, hey, here's how to use the program. And then for parser, basically does the same thing. Now, parser again has a lot more flexibility. Doesn't like --h. Well, that's embarrassing. Huh. Okay. Well, anyway, I guess I'll have to work on that. I mentioned before, so I'll mention again. the inputs can either be a binary string from a file or a binary string right there on the command line. It can be a sentence or one or more sentences in a file, or a single sentence that's right there on the command line, or apparently -h, but not --help. Anyway, so it gives some samples of what things might look like. And so where I want to get you to, though, is timestamp. So let's go over here and let's give a -h here. So what's going to happen here is I need to connect to my data feed. In almost all cases, my data feed is going to be some online site. So I need an IP address or I need a host name, and I'm going to need a port number. And so the parameters that you really need to make this work is minimally, you need an IP host name or IP address. No error checking is done on this, by the way. If you put in, 1.259.3.-87, okay, obviously you won't be able to connect to it, but the program won't be the one to say, hey, that's not a. So I need a host name or IP address. I need a port number. If you're not using TCP, you need to specify the protocol. And then I say, well, how many seconds do I want to gather data? And do I want this to be verbose or not? So verbose means that I actually see the data that's coming in as it's coming in. So so here, let me give you an example. So let's do timestamp.data.pl, and I'm going to get my input from a research site that a colleague and I share at Embry-Riddle Aeronautical University, from where I am retired. So there's my IP address, my host name. The port that I want to use is port 4000, and let's just grab 20 seconds worth of data, and I want to see it. So we did get a connection. That's good. You can see the output file is going to something called AIS underscore. It's a date timestamp. Oh, thank goodness we start to see stuff. So what's happening now is you'll notice what is writing out there is the current date, the time, the Unix time, and the AIVDM message that I just saw. The Unix time, of course, is essential because if I want to get relative time, I'm going to do relative time based upon the Unix time. So I can see that these two messages were 9 seconds apart. That's trivial if I'm looking at the Unix epoch time format. Obviously, looking at the other format is so as a human I can read it, but I sure don't want to have to do time comparisons based on that. So, okay, 20 seconds wasn't very long. I'll probably time out once it gets the next message and realizes that more than 20 seconds have passed. So it got these 3 records, and they are in that file there. So if I were to take a look at that file, really, okay, it got that. It's the only one today. So you'll notice all of the information that we just saw that was more or less, human readable when it went to, the standard output. I've got 3 records in here, and that's now my timestamp data. Now, doing this for 20 seconds is interesting to show people, but if I'm trying to gather data, obviously, this is something I would run for 10 minutes, an hour, what have you, and that'll be some of the stuff that I am about to show you in a minute. So actually, I'm going to open up another window. Let me, let's see what this looks like. Okay, that'll have to do. So, all right. Want to be sure that I'm in the right place for what I'm about to do next. So, again, in the PowerPoint that you'll get, this is the timestamp data demo. So Play AIS was designed to go back now and read that character delimited file that contains the timestamp. And again, we're more or less looking for a Unix epic timestamp and the AIS sentences. And now I want to be able to broadcast this out to an IP address and a UDP port. One of the other things is I decided I wanted to be able to, play this faster or slower because, playing back an hour's worth of data in an hour may not really be what I wanted to do. So the help file for this, again, sort of tells you how to run this. What I'm looking for is I need the data file, and the output's going to go to a TCP or UDP socket somewhere. I need a file name. I need an IP host. I need a port number. If the protocol is not TCP, I need to identify the protocol. If I want to play it back at something different than real time, I need to set the rate. If I want to see it as it comes out, I can set verbose mode. And I also need to tell what is the field separator. When I'm using my own timestamp program, the field separator is the pipe symbol, but somebody might be using a different delimiter. So, I need to know what that is. And then I need to know in what field am I going to find the AIS sentence? And in what field will I find the timestamp? So remember, if I go back and I look at, let me go back over here. So in the 0th field, I've got the year. And so here's field 0, 1, 2, 3, 4, 5. The time is in 6 and the sentence is in 7. So that's the default for the program, that the time will be in 6 and the AIS sentence will be in 7. But again, you could have a different format and the program is designed to, accommodate that. So in any case, I told you that so I can tell you actually some other things. Again, okay, that's what the help file looks like. This will be in the TCP, and here's what would happen if I start to play something back. So I actually am going to start to play something back. Let's just, for kicks and grins, play back something else. Well, actually, oh no, this will be fine. Let me go back over here to Opencpn. And I want to bring this up here, and I want to, make this just a little bit larger. Okay, so what I'm going to do is, let me go back here. I want play again, but the input that I'm going to use is a file, AIS underscore 2021-0706. That should be right. And I need this to go port 8888. And in this case, the IP host should be my local host. Because, as I told you, I'm not, really broadcasting this out over the air. So if I run that, let's see if that'll work. Okay, it's connecting. And I didn't use verbose, so it's not showing up, but that's okay. Somewhere here, I'm looking for a boat. That's one of them. So if I do a target query, you'll notice that this says that was there, 22 seconds ago. It's a sailboat. Actually, Fiasco was there on July 6th, because that's when I captured this information. So you'll notice right here, right up here, there's TCP and it says 000.:8888. So these 3 messages, or now there's 4, these are all being broadcast out today. They were all captured on July 6th. So there's the Fiasco. There should be something called the Naughty. The Naughty, that's it. The Naughty is here somewhere. Should be around the same area. Oh, there it is right there. Yeah, so there's the naughty. It's a pretty big pleasure craft. Could have a lot of pleasure in a 19-meter boat. But anyway, so that's there. So again, all of this is basically combined with real data. So the significance of this is this. Suppose you're a boat and you've got AIS and you're getting bona fide AIS data. And then all of a sudden, you start to see other things pop up. Well, you can't tell the difference between a valid target and an invalid target. And, that's why I more or less care about that. Now, one of the other things I want to show here, I'm going to do this again because I really, well, actually, I don't need to do it again. What I'm going to do is I'm going to, I want to show you the entire file. So there's the entire file. Now, you'll notice that there's one message that really stands out as looking really, really different. It's this message right here. And it stands out just because it's longer than everything else, right? So I'm going to go over here. And what I want to do is, am I in the right place? I'm in the right place. I want to parse it just because it's interesting. There's my sentence. And let me escape out of all the special character things. The ats actually are, as it turns out, are okay. It didn't like that at all. Oh, I missed one. God, I've probably created a spurious file out there somewhere. Okay, so let's take a look at this. This is a message type 21. It is an Aton report, an aid to navigation report. Now, in this case, because the MIMSI, this number here, starts with a 99, it means this is not a ship. This is an Aton. Okay, that's what we expected. It's an Aton report, right? The 367 says this belongs to the United States. If it's an Aton, that means it belongs to the Coast Guard, probably. Anyway, this is an Aton type 29. It indicates safe water. And its Aton name is CC. I happen to know that that is a Aton buoy down at the foot of Cape Canaveral. And in fact, if I look at, I'm gonna try this again. I'm gonna do another live demo with Google Earth or with Google Maps. We'll see how this works out for me. We are in water. Let me scroll in a little bit. Scroll in a lot. And what we're going to see, and we're going to see this again in the entry channel into Port Canaveral goes from about this point, from the welcome buoy, that's the CC buoy, this way. And then it goes west through the dugout part of the channels. Anyway, that's how you get to Port Canaveral and, all the docks for the big boats there. Now, it turns out that I found this message was pulled up in here, and I thought it was interesting, but it became more interesting for some of the other stuff. So I've already told you about the naughty and the yes. There's the odd message. We just parsed it. That's where it is, all that kind of stuff. So the code that I have and that I've shown you here, you can download this all from my website. There's a URL later on, but if you go to GaryKessler.net, you can find a link to the software. And the software license that I use, basically, more or less, I make no guarantees about anything, but as long as nobody tries to assert that they own it, they can pretty much do whatever they want with it. If you do make substantive changes that you think I'd be interested in, I would certainly like to know about it. A number of people have said, "Ooh, is it okay if we port this back over to Python?" And I've said, "Yeah, sure." And I haven't seen any of that work yet. But be that as it may, that doesn't matter. There's some stuff I want to show you. So this is a picture of my wife in Hawaii trying to herd fish, sort of a metaphor for maritime cyber. But so a couple things you should know about. There are a couple ways in which you can generate some NMEA 0183 data if you want. There is as you can see here, there's an NMEA simulator that you can download online. There used to be an NMEA simulator that was a plugin for Chrome. They have, I believe, discontinued that, and this is the replacement for it. And this is a standalone program. I have it working on my Mac. I believe there's a Windows version. I don't know what other versions they may or may not have. But you can also see in the lower corner here, I made an error in something I said earlier. I said that the other symbol, instead of an exclamation point, was a pound sign. I was wrong. It's a dollar sign. But you can see these other things, many of them are GPS messages. And again, these are the parameterized messages. So all the parameters are merely comma delimited, and you can actually read them. And if you know the format for that message, you can actually figure out what the values mean. In any case, there's a couple demos I would like to do for you. And let me just go back up here for a second. So let's go back out here. I'm going to shut the Nmea Debug window just because it's taken up some room that I don't want to take up. And there's a couple things I want to show you, like I said. Oh, there's a ship out there. What's that doing? Well, there's the Mimsy. It's a ship with a Madeira flag, and that's pretty much all we know about it. Not telling us where it's going, but it's cruising 21 knots on a course of 352. Could well be going up to Jacksonville or something. Not one of mine. Not one of my fleet. All right. I'm going to take you down to the area of Ponce Inlet. Here's Ponce Inlet. So let me go back over to play. So I have a file here. I'm going to show you some ghost information from Ponce Inlet. What I'm going to start with is this. So one day I just started getting data, and so I captured here only about, it looks like only about 4 minutes of it. But I've got 4 minutes of data from 2 ships. So what I want to do is I'm going to play these. So that's not what I want. What I want is Ghost Ponce. I'm going to run the shell. And so the shell is now sending out this data. And I'm going to go out here. And there's going to be 2 boats are going to appear. Not Bandit, but in the area of down here. We should hopefully very soon. This demo generally works just fine. Where are my boats? Well, heck. Oh. Let's see. Well, this is sort of embarrassing that I am not finding the one I want. Well, never do live demos is what we learn. Well, the Aton one will work. I'm going to get out of this. I'm going to do another, try another live demo because I was so successful with that one. Let's see how this one works. Oh, that one's working. Okay, good. So I can't explain the other one right now, but I'll tell you about this one. So, well, that's popping up all that stuff there. Let me go over here and okay. So here what I have are a whole bunch of Atons. It's not exactly clear from here, but these are all virtual Aton reports. And I have them pop up pretty quick. You can see, I mean, the relative time, 1, 2, 4, 5, like I said, I just made this stuff up. But so here's the story that I want to tell you. For those of you who know how to read, you know that the lighter color, the whites and the grays, are the deeper water, and the blue is the shallow water. So here is Ponce de Leon Inlet in Florida, and you will notice the red and the green channel markers are sending you up here on the north side of the inlet, because that's where the deeper water is. That's the dredged part. The inlet, though, is pretty wide, and people who don't follow the markers, or when the markers get blown off station due to hurricane, and they don't watch carefully, they can end up here in the shallows. So what I did, though, is I've created some ghost Atons that might appear on your chart plotter. So right out here, I have one. If I do an object query, well, not an object query enough. Let me try to get closer to it. That's the number 2. This is the one I really want. Yeah, let me go back out a little. Okay, so here's something called PI. This is a virtual aid to navigation, and it says that the preferred channel is on the starboard hand. What that means is, if you're coming in here, there's a preferred channel and a secondary channel. To get in the preferred channel, you want to keep this one on your starboard side. That means you're going to come down here. So the one that's marked has just become the secondary channel, and this is the one that has become the preferred channel. And you'll notice here's the number 2, which is exactly what you would expect. And it's a starboard hand mark. It's a number 2. It's red. And this one, by the way, is going to be 3. And there's 4 and 5, 6, 7, 8, and 7A. There's a reason I did that. And that's the other end of this. The point being is, if you're a big ship and you don't know any better, you're going to come to the south here. You're going to come in between these. And even when you're a little bit well off, you're going to run out of water. Because while this area is 25 or more feet at low tide, this area here is at about 3 or 4 feet at high tide, maybe 5. But the point is, you're very quickly going to run out of water. By the way, here is the sunbolt again. That's the the thing I was inadvertently running before. This is a ship, or a boat, that is actually blending its way off course through Ponce Inlet. So that ship didn't exist. What I was trying to show, and that was the one that I was embarrassed that I couldn't find, but I'm going to find it now. There we are. There we go. Okay. Making myself a little note here so I don't make that mistake again. If we go offshore here in Daytona, we're going to see 2 boats. One of them's going to be here. If we look, they're both going to just sort of appear. There we go. Okay. That's not Bandit, but under that's a boat called Jupiter. And then we're going to see another one up here called Sea Fox. Here's the Sea Fox. There's a Mimsy underway, all that kind of stuff. And under here, like I said, is the Jupiter. I don't really care about them right now. Oh, you notice that Sea Fox just moved. So Both of these vessels were here in February of 2020. That is when I got the data. If you're driving along here and all of a sudden you see those boats plop up on your screen, as far as you're concerned, they're legitimate targets, and you're going to move. A number of people have said, yeah, that's a cute demo, Gary, but who cares? They won't show up on radar. Well, great. That's fine if you have a boat with radar. Tons of boats are running with AIS, and they're not running with radar. And I would argue that it hardly matters. And it hardly matters for the following. So many of you have been reading about the warship spoofing that's been taking place in the Black Sea with NATO vessels. And as a result of some of this, what is almost undeniably AIS spoofing, we have, Russian President Putin saying things like, I feel that I have a right to start, bombing American and British warships because based on false AIS information. So I want to show you how easy it is to do this spoof. So first of all, if you want to create a ghost AIS track, find a ship, any ship. In my case, I went to Wikipedia and I said, I want to know about Russian warships. So there's a Wikipedia page that lists all the Russian warships, or at least it purports to list them. And then I found one I liked, the Moskva. And so I said, okay, cool. Well, there's a Wikipedia page for the Moskva. And I was able to get a picture, and I was able to get some other really cool information, like everything that's here. And based upon this information, I was able to make an educated guess as to the Mimsy. So the next thing I need to do is, well, let's find a location. Well, I decided I'm going to go find my nearest deep water channel that has a welcome buoy. Remember that CC buoy down at the foot of Cape Canaveral? Let me shrink this a little bit, and let's go down and find Cape Canaveral. Here's Cape Canaveral. Let me make this a little bit bigger so I can actually see it. So here, by the way, is that CC buoy I was telling you about. No, I didn't put this here. It's actually really there. Here's another buoy you should know about. This is the number 11. The number 11 is another version aid. Well, okay, it's number 11. It's green. It says there that it's a port hand mark. That means it's going to be out on your port side. Notice, by the way, this Aton, well, actually, this is a real Aton. It's more than virtual. This is a real Aton that also has it's giving you its Latin long. You'll notice the report age number keeps ticking up there, and then will occasionally go back to 0. Because this, I believe, is rebroadcasting its information every 8 seconds. The CC buoy, which is merely a safe watermark, also looks like it's about every 8 seconds. So in any case, let's keep this in mind. So this is what I wanted as my area. And so then what I did, let me go back here. So now I need some data. I need to make up some data. So I decided, there's been a big problem when the HMS Defender, I believe it was, the AIS tracing showed that it was 2 miles off of Sevastopol. Well, I figured, okay, if somebody can put the Defender 2 miles off of Sevastopol, why don't I put the Moskva 2 miles off of Cape Canaveral? So that's what I did. Like I said, got an educated guess on the Mimsy. I decided to put it in a place where, if you get a little bit closer here, what you'll see is if you go in this channel, they want you going in at 310 degrees. So I decided, okay, I'll make that my course. So my course over ground is going to be 310 degrees, popping in 15 knots. That means that I need to be, as a vessel, my reporting interval is going to be every 6 seconds. So what I then did, let me see where I am here. Hang on just a second. Oh yeah, okay. So what I did was I sat down and I made some notes. So there's the Latin along I wanted to play with. I decided that I wanted to do a minute worth of a spoofed course. So, there's my course, there's my speed. And I cheated. I just made this in a straight line. And so reporting every 6 seconds. I figure, well, feet. At that speed, we're moving about 200 feet in 6 seconds. And so and I'm moving in a straight line because I made this simple. So, you can sort of see I just have a bunch of lat long. So then what I did was I ran the ping program. Let's see what I don't actually need that one. Okay, well here's my set. So I ran my menu program once, and that gave me a ping output, and for this type 1 message, and then I ran another menu iteration using type 5, and then all I did was I took the first ping line, and copied it another 9 or 10 times, and all I did was change the latitude, longitude, and the little timestamp here. And that's all there that's interesting. And then I put this together, into a shell program. So let's see what happens when I run that program. So let's do Ghost Moskva, and it's starting to send information out. So let's go over here. Lo and behold, I have a boat. Wasn't there a minute ago. And when I do a target query, lo and behold, it's the Moskva, and every 6 seconds is going to move. So we missed the last one, but 5, 6. There it is, moving 200 feet per second towards Cape Canaveral. It doesn't look like it's shooting straight in. Its course is about 310, but its bearing is about 315. Going at 17.3 miles an hour. So up here, you'll notice that I've got the Moskva, I've got its call letters, I've got its MIMSI. It's a Russian military vessel underway. It's 186 meters, 20 meters in the beam, 8.4 meter draft, and destination, U.S. Florida Canaveral. I don't know what the real code is, but I figured that would be fine for a demo. And it was just that simple. If I wanted to do something a little bit more complex, I suppose I could have actually sat down with a chart and charted where I wanted the vessel to be, and then I could have just gotten the lat longs that way and write do all of this. But I guess my point is this is not the hardest thing to do in the world. And if I can do it, I figure pretty much anybody else can do it. So there's the picture. It'll be in the PowerPoints. Anyway, that's really what I wanted to show you. I know I took a long time to do it, but these are some of the tools that I developed, and I use them for all sorts of cool demo stuff like this and research stuff, and hopefully other people can use them as well. If anybody wants to share with me the kind of stuff that you do with this, I would be very interested in that. I do know of a couple places. One actually, a guy in Japan who found an error in one of my programs and it. But I do know of a couple groups that are using this for a variety of purposes. So far, everybody I know that's used. But anyway, that's what it's there for. In the PowerPoint, also all the acronyms and abbreviations. I've got a little bit of a reading list of where you can get more information. Not the least of which is there's actually URL to get my code, and there's also a document that I wrote about using Raspberry Pi for my AIS, and that'll give you some information also where to get some data. And yeah, that's pretty much where I was. So I'm going to stop sharing the screen now. And there we go. So anyway, if if anybody's got questions, I'm happy to hang on for a little while because I know the session is still open a little bit. And clearly, if you have email questions, feel free to pop me on email. I'm not the biggest fan of Discord in the world, but if you can actually find me on Discord and I can find your question, I will answer. So I'm done for right now. Oh, let's see. I said I was going to stop sharing the screen. now. Oh, there we go. You can see me drink my water.
Microsoft Storage Effect CD 2020-1300. It is a directory of Aton vulnerability. You can see that the
Okay, folks, I'm going to bug out. If anybody needs me, you know how to ping me. And thanks for being here. Take care.